Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're working on our spell casting, right? We have the water spell being cast like that, which we need to trigger entities to become splashed with. That's all fine. The issue comes with spell casting over here. If we spell cast a fire spell and then switch to a water, we get a permanent fire kind of particle system around us, which shouldn't be happening. And then as well, once we trigger in the entity the splash, we get a flashing on the blue fire, and you can see the fire is still active because we just cleanse that gecko with the fire, which I do think this effect is cool without the fire. We might do something kind of similar with the yellow tunic once we add that for illuminating the dark over here. You know, but this is not what we're trying to do. We need to rehaul our casting system, because when we made all this fire stuff, we made it in mind of there's only one spell, because in the demo there's only one spell. So when we go to Aqueous, when we swap it over, something's not getting flushed correctly, making this fire active the whole time when it really shouldn't be. So my first instinct is to test the original commit before we started making these changes, because we started migrating some logic from our gecko walk state and our projectile, our water spell projectile. So the first thing I want to do is see if we can get stash our changes. Actually, let's just look at what we've done differently. We move this aqueous logic into the entity instead of the gecko walk state. So we took it out of the gecko walk state here, moved it into the entity class, hoping that it would fix our issues, and it just caused many, many more issues. But I also didn't try to change the spell going into this, so it might have been broken like this already, which is what I'm about to test. So what we can do is get stash our changes, and then it reset to our recent commit here from 2 days ago. So not yesterday's code, but 2 days ago code. And I'm just going to see if we can recreate that with switching. So we're going to go fire spell. We're going to cast our fire spell and then switch over to Aqueous. Mid successful cast. See, look. Huh. It didn't keep it on. So, well, yes it did. Yes it did. Shoot. Okay, well that's half good, because that tells me that this was already, you know, we didn't break it trying to add our stuff into the entity, but it was already broken, which is not good, but at least we know what we didn't break it. It's just broke. So as good of news that is. How would we fix this? We need to see how it, and it's like when I added the first spell, we have a spellcast entity table, I think, in our scene, and whatever level Aqueous or whatever level Flama you've got unlocked, we kind of set the spellcast entity count and then go ahead and update it. And then we don't check for collision unless it's in the successful cast range, but we also man, I really lost the train of thought there. But yo, thanks Kivictus for the battle royale. Thank you. We'll see how this goes. Hey Ziza, welcome in. Man, I think you just missed the battle royale, Ziza. Yeah, I think the move is we need to make sure our spellcast entity table, wherever that may be, is getting flushed and or not updated and or not rendered if Aquis is equipped. Therefore, we don't have the collision check. Therefore, we don't have the render for Flamma when a whole nother spell is active. Oh my gosh. Are you going to get the health packs, Cavictus? Oh, dude, you turned away from the health packs. You fool. You fool. Okay. Part of me wants to go back. Well, yeah, part of me wants to reapply our get stash. Dude, did you really win that one? You really won that one? I looked away because I was like, surely I got him. Surely I got him. Oh, good job. Good job. Good job. I gotta watch that back. That was good. That was good. You got me on that one, Cavictus. Okay. Yeah, I don't think I'm gonna apply our stash. I think we're just gonna go for it. So let's take a look at how we're doing this spellcast entities. It looks like in the scene we init a spellcast entity count. It's really kind of strange we do this. Good job, Cavictus. That was a good one. Man, it is a little wild to see what we did for this. But look, here in the init for the scene, we're saying give us 3 spellcast entities, and here's the params, and then go ahead and set them to the flame idle animation and state. But then we're tweening this in a circle. See, and it shouldn't be called spellcast entities, it should be called Flamma entities. Okay, and then here, this is where we're updating them for the circular motion and updating their position and then rendering here. Okay. So at the very least, you know, we need to kind of check, because I think what might be happening is the spellcast entities are always circling around us, but when we switch to Aquis, we're not fading back down this spellcast transparency. See, we have this spellcast fade right here. That's just whether or not we see it, but I think the issue is we're still checking collision in a successful cast, even if Aquis is equipped, and that's triggering the realization that the spellcast entities are actually colliding right in front of them. So that's why they're still interacting with the geckos, even though Aquis is equipped. So we need to fix this first. Okay, sounds good, Cavictus. Yeah, get some sleep. I bet all the winning. I bet you're tired of all the winning you've been doing. Thanks, man. Thanks, man. Yeah, peace out, Cavictus. Okay. So we can go about this in a couple different ways. We could flush our spellcast entity table. I don't want to do that because we kind of init them with 3. So if we ever flush them, then whenever we swap back to a Flamma, we need to check the level of the Flamma upgrade and then repopulate the spellcast entity table. That doesn't sound all that fun. I'm not terribly opposed to just keeping them around us. I really don't really care that much. It's just 3 entity positions, you know, it's nothing. But we do need to at least look at the mechanics of this spellcast fade opacity and make sure that when we switch from Flamma to Aquis, that whatever needs to be happening is happening, like flushing our spellcast fade, making sure we're only incrementing our spellcast fade if Flamma is equipped, not if the focus indicator's in a successful cast range, which is a whole bunch of jargon unless you know the code base. But talking through it kind of helps me get a game plan for it. So let's do that first. Let's check the spellcast fade and make sure certain things are happening the way we want them to. So it's called spellcast fade here. Oh, spellcast fade clamping. Okay. See, that should really be render Aquis, not render spellcast. See, we do it just in a successful cast. So let me print up this successful cast. Is this global? I think it is global. Yeah, it's global. So let's print up the successful cast and see if Aquis casting counts as successful cast, which I'm pretty sure it does. Let's see. So it'll be... Maybe we do it in the play state, where we render our debug info just like this. And we want to do something like print successful cast. And we're going to concatenate the actual value of our global successful cast variable, and we're just going to concatenate to the end of that string on screen here in the play state, so we should see it. So we got a successful cast false. Now if Flamma is balancing in that green, it's true, which is looking right. But also if we've got Aquis, oh, see, look, it's not doing it. Okay. So that's good. It's just that in our successful cast, fade, spellcast fade. Spellcast fade. We're doing this thing where we should be draining the spellcast fade. Okay, let's look at the value of spellcast fade and print that up real quick. Okay, so this fade integer is the number of the opacity out of 255. So as we cast, it'll fade up to 255 and be clamped there and fade back down to 0 to fade away. I'm going to swap it. While our fade is at 255 to see if it drains. Oh, see, look, it doesn't drain. So it's not draining here because we're in a successful cast true. So that's the issue here. So we need to make sure we should change the name of this to be successful Aquis cast, but when we go to equip our spellcast of Aquis, we should make sure both spellcast fade is 0 and the other value is false. Successful cast is false. So let's go to where we're equipping spellcast equipped, right? Or what do we do? Is it not spellcastic? No, what is it? Spell equipped? Oh man. What's the value? Element equipped. Yeah. Once we do element equipped equal to aqueous, if we swap to aqueous, what is this? If our selector's on aqueous and we have it unlocked, then we're either going to equip it or unequip it. So this would be the equip. So once we equip it to aqueous, we want to do these two things. We want to set our spellcast fade back to 0 so we get no opacity on the spellcast entities of Flamma that are going around us. And then we want to get our successful cast to false. So we're going to try to recreate what we just did, which was have fire on screen with aqueous equipped. And we're going to see if we fix that issue. Okay. That looks right. Now let's just make sure we don't collide with the geckos at all with our fire or anything. Because in reality, those spellcast entities are still circling us. We are updating them, but we are not rendering them. And they don't do collision unless they are... I think unless they are... unless the Flamma spell's equipped and we're in a successful cast range, which right now we aren't, because successful cast is only for Flamma, which is why we need to rename it. But this is okay. This is okay. So that fixes that. Let's probably commit this. Let's see. So we reset our spellcast fade and successful cast, and then we added some debugging. This is okay. So play state 961, we can afford to lose. Yeah. And just for finding purposes, I like to call it debug right there. Okay, well this looks good. Yes. Okay. So this is what would we call it? Fade out, something with Flamma. Let's say Flamma opacity reset. I mean, we'll just call it what the code calls it, which is spellcast fade. Spellcast fade and successful cast reset upon aqueous equip. Yes. Okay. So there's step one. We could go check our stash and start re-implementing the changes we did, migrating the splash from the walk state, the gecko walk state, into the entity state. But I think we're really just gonna continue as is here. One really hard part about this, let's take a look at how we're doing the splashing. So we have this thing called splashing, and right now I think we're doing a timer, right? Yeah, we're doing a splash timer. So if we come in here and say, well, after 3 seconds, let that entity become splashed and set that entity's particle system to a splash particle, which should be gecko splash particle, I think. Do we not have this gecko splash particle? Really? Let's leave it there. Let's see. We're looking for the blue. We're looking for the blue splash after 3 seconds here. There we go. Okay, so he slows down he becomes splashed, which is just flashing. Nothing in his AI changes. He just starts splashing. So the thing is, right now this is in the walk state. We're saying, oh, if the entity's in the gecko walk state, that's the only way this splash exists. What we want to do is move it into the entity class so that any entity can become splashed, like a bat can be splashed and become slow, stuff like that. The issue is we're also an entity, and we shouldn't be able to be splashed. I mean, I guess, you know what? I guess we could be splashed. Why couldn't we be splashed by like a boar or something in the forest, you know? But we were having an issue when we went to implement this, that the spellcast entities were also entity instantiations, therefore they had a splashed, and then the fire was being splashed for some reason, which was horrible. So we'll refactor small bits at a time, trying to take out the splash from the walk state and move it into the entity state, and see what issues we may encounter. Let's make sure that all geckos become splashed after 3 seconds. Yes, and then they slow down. So that's pretty good. We could also, like, you know, we can change the linear acceleration of the particle system to make them sync rather than be the spiral if they're nerfed with a splash. So I think that could be cool. And then we need to check collision based on this blue circle we're rendering here. We will turn that off, the render, but that's the collision we need to test. And I think it'll be simpler than I think that I originally thought it was, because I was like, how do you do collision for a circle? I only know AABB collision, but then I was kind of thinking about it, and I think circle collision's even easier than AABB. We just check the center point plus its radius for any collision with a side of a rectangle. So I think that should be fairly straightforward. Let's see how we can start implementing this. Okay, so see how this is in the gecko walk state. So we need to copy, you know, we need to migrate anything that's here into the entity. So we'll start here and we'll go into the entity. And you know what? We're in our other window. Yeah, we'll do it from here. So if we go in our walk state, we're going to pull up anything that has to do with flashing. And we're going to move it from the walk state into the entity state. So let's do that. Entity state. Okay. Well, now our entities will have a value of, it's not flashing. It's not flashing, actually. It should be splash. It should be this splash timer. We don't even init this. How can we increment splash timer if we're not initializing it? This should be impossible, right? We can't just increment a non-initialized number. It's working though. No, I must have, dude. Okay, I must have deleted it. I must have accidentally deleted it. Okay, it was these two. Okay. So it's splashed and splash timer. Okay. And you know what? I can't move this. Splashed and splash timer. That wasn't it. splashed bool. We default to not splashed. And then we have a splash timer. And this, we probably won't need splash timer. This is just for testing the triggering so that we don't have to get collision also working right now. So we increment our splash timer. We become splashed. We set a color. Modify our walk speed. Set our flash timer. Splash timer. Okay. So in our update here for our entity, we'll just put it right here in the update, wherever. And look at, we have a note says move splash into entity. So that's what we're doing. And it's a self.splash timer now that we're incrementing. So we initialize it, we increment it, we check for 3 seconds, we become splashed. We don't need this dot entity because we are the dot entity. And then where is this gecko corrupted particle? See, how is it that we're setting it to the corrupted particle color, not our splash particle. So how our splash particle is heavy on the blue. We are changing to blue, so something's working, but we don't do a splash particle. Oh yeah, we do. If we're splashed, okay. Oh, we do it in the entity particle system here. Okay, because we were setting color over here with the emission rate. Okay, so we could start doing this different acceleration for it as well. Just to try, like, I don't know what 10 would do. 10 and 2, I don't know what it would do, but let's see what that looks like. Entity 191 is not working because we don't have a self.entity splash. We just have a dot splashed and a dot walk speed. 196 it does not like. The flash timer. We don't have a flash timer. Because it should be here. Pulled from the entity, pulled from the walk state into the entity. So we say also this flashing and flash timer. But then when we go to render, we need to actually set the color, right? Oh, see, look, we're flashing. Oh my God, dude. See, this is it. This is what I'm talking about. So we're flashing. For some reason, the gecko is, it looks like our tangential acceleration did work. 10-2 must look like that. We want to make it kind of sync. You know, I'm thinking of like in Pokemon when you get like, you know, your speed fell drastically and has like the downwards blue stuff kind of like that. So we might do a different acceleration than that, but also our flashing is jacked. So our flashing used to be here in the walk state, but didn't we do something? You look, if we're flashing, we're gonna do this, which is before we draw, we're gonna set our color to this. It's flashing blue in this scenario. So if flashing, it should be called, oh God, I don't know what it should be called. But we're not doing this anymore here in the walk state. So that's partially wrong. So in our entity, we need to do something like this, but we already have a flashing in our entity, don't we? For the render? Yes. Okay, so this is why it's messing up. Because flashing for Tashio is red, but flashing for anything else. So if we search for flashing, we go to the top one. Let's call this blue flashing. So we're not blue flashing, and then our blue flash timer also needs to be set. So when we come here to do our flashing stuff in our update, we need to make sure any flash timer is actually blue flash timer, and we need to make sure any flashing is blue flash. So this should be blue flash timer, blue flashing, blue flash timer. Okay. Okay. Let's see if that stops us from flashing at least. Okay, well, we misspelled timer right here. Okay. Let's see. Gecko should flash. Okay, well, it changed particles. It didn't flash, but we aren't flashing, so that's good. Our particle acceleration also changed, but our gecko is still not flashing, and that's because we're not setting our color to blue. So this should be moved from our walk state into our entity state, and our entity state is before we draw our thing, before we draw in the render. Yeah, before we render the entity, we're going to set our color to a certain color. If our blue flashing, we're going to set to that blue, otherwise default white, then go ahead and render that entity. So we should see a, oh no. This is the issues we were, this is the issues we were about to talk about, man. Okay, well, the gecko is getting triggered right upon splashing, but we are flashing for some reason. We can do this. I don't know. The set color white here overrides our spellcast fade opacity value, which is why the part of the flame is flashing blue. So that makes sense to me. So I think we have a field in our entities for an enemy status, like if it's an enemy, because we don't, well, the only one it really is affecting wrongly is the is it us? We're flashing blue. No, we're not flashing blue. Yes, we are. Okay. Okay, so we are flashing blue for some reason. Why is that? It's because we set blue flashing to true right here after 0.2 seconds. We just trigger that flashing. Okay. So I think what we want to do is we can either omit the blue flashing for entities of type player, or if we did have this entity definition of entity gets this. No, when do we initialize? We do a Tashio init, right? This was in our stash that we moved. Where was it? In the scene? Man, dude, we gotta find this. We gotta find where we init the player. We left a note in our stash, but I don't feel like recovering that right now. Just to check. Where would it be? We have... I mean, isn't it... It's just when we assign the G player, right? Yeah. Okay. I'm thinking that our entity class or our entity defs need to have an enemy field or a type field that we can kind of control which types can be splashed or not. So we have an entity, and an entity does have blue flash and everything, but we need a type. We define a type for our bats and stuff, but we don't for our player. So let's go back to our player and say, well, we already have a type field. We're just gonna call it player in our player init. So that is a, it's kind of weird, because where do we say that our player is an entity? Because we're assigning a player class here. Let me check the player class real quick. And we just kind of init the entity like this. This is how Love2d is kind of handling inheritance in a way, because we say this class includes the entity class, and then we can go ahead and init an entity with itself. So that's why the player's an entity, even though when we initialize it, we don't say that. It's just that the class kind of treats it as also an entity. So that's why we're flashing. So let's go back. Now we have a type player we just added on here. And now what we can do is, instead of... Yeah, what we can do now is say, when we go to change the color in the entity via this stuff, I still don't get why this is blue. We do it if we're splashed, so this actually isn't doing anything. Right, so if we do splashed, if we look at splashed, are we not? Oh, splash particle right here. So where is this? 269. Okay, we set it. I want to have a... This is like the particle system update we're doing this, which doesn't make sense to do the flashing color change logic inside the particle system update. That doesn't make a lot of sense to me. So maybe we'll move this. But yeah, it looks like we don't need to do the color change that we've been doing right here. But let's keep going. Let's keep trying this. We need to... You know, we either need to... Gosh, I don't know. It's tough with the triggering, because on one hand we're triggering it based on the timer here, and then we're flashing blue, which let's just say and not self.type equal to player. So we only set this blue color if we're not a player type of entity. This is not right. Let's see if we flash. We still flash. Fuck. Okay. How did this go about? We're setting the color to be white here. So where do we set the color to be white? Right here, if blue flashing. So let's do the blue flashing here and not the type equal to player. So we will not change our player to blue. And that means we have to say also the flame. If the flame, see, this else is really screwing us. I think we leave out the else, because when we do the else there, we overwrite the spellcast fade. But then here we should prevent the blue flash. If we're a type of player, we shouldn't set the color. Okay. Looks like our spellcast is looking okay. Do we have the opacity? It's working. And the aqueous cast looks like it's working. Gecko should flash to blue. He's not flashing. We're not flashing. So that's close. You know, the tangential acceleration got set. And the walk speed. So half of flashing is working. Half of blue flashing is working. But if it's blue flashing and not type player, that should work. I mean, unless, yeah, you know what? Because the gecko wasn't flashing here either, was he? We need to do a... That is so wrong. Oh, he was flashing. Oh my gosh. Yeah, he is flashing. Okay. So he does. So this is getting wrong. If blue flashing, we do want to set this, but if we're a type player, or a spellcast, like a Flamma spellcast element, then we want to reset to white. I think the conditional was screwing something up there. I'm not quite sure. But we're going to set the color to blue. Let's see this. There we are, back at it again. Okay, Gecko's flashing and spellcast entity, so we just need to omit our spellcast entity from this. At least it's not active, right? It's not a successful cast, so it's not actually cleansing him, which is good, but whatever our spellcast entity is, we need to give it a type of something so that we can also omit it right here. Let's just call this blue flashing just because. We need to go to our spellcast entity and give it a type and define it as spellcast or Flamma, something like that. If we look at our spellcast entities, whenever we initialize them as an entity class, that's when we want to do this. So we do it right here. Oh, perfect. We already have it. We already have a type of spellcast in the entity. So here we're going to say, well, if it's a type player or type... Actually, yeah, how would this work? Because we want to set it to transparent. We want to ignore this. We basically want to... and not... self.type spellcast. Then go ahead and do that. Okay. And then we set our player to white. This should work. Okay. And 3, 2, 1. Gecko is not turning. which is not good. It has to be not a type spellcast, and the gecko is not, I promise you. We're having an issue. This is in the entity render. Okay. If we're flashing, if we're not a type of spellcast. See, we already kind of had that. If we're not a type of spellcast, or player, right? Oh, no, this is the player's flashing logic, so that makes sense. Okay. We're close. We're close. Okay. Let's walk it through. Let's get rid of this. Because we're still flashing blue. The spellcast, right? As soon as... Yeah. So spellcast is flashing blue. Because spellcast is an entity, and we're doing it here. If blue flashing, and we can't do a compound conditional there. I don't know why, but if we can say, if not, let's do this. If self.type does not equal a spellcast, then let's go ahead and try this, which is setting our players okay, if it's not a spellcast, and if we're blue flashing, we're going to go ahead and set that blue. But if we're a player, we're going to reset it to white. It's like, it seems so stupid because it's kind of stacked like that. But it's working now. Gecko's flashing. Player is not, and Flama is not, and we still have the render working. So the spellcast entities are still there. The render's fixed. The render on the blue flashing is good. And also, if we switch mid cast, oh, well, that's an issue. Okay, well, this is okay. We need to do something with the Aquis casting, because right now successful cast range for Flama, but Aquis is not equipped, and Aquis is coming out. So that's at least the next thing. We should probably commit here, at least as a checkpoint. Let's take a look. We moved the blue flashing, a little more better named, into the entity. And then we set the blue flash timer, because flash is a red flash, so blue is the blue flash. And then we took out that flashing from the gecko walk state. And then we defined a type of player on our entity, on our player entity. So that's all good. That looks good. So we can say this, add blue flash to entity class instead of walk state. Good. And then now we need to just make sure we can't cast Aquis when Flama's equipped. So if we do this, yeah, this should be impossible. Okay, let's take a look at our Aquis projectile. Now, when do we kind of initialize it or become successful cast, what cast landed, aqueous casting. When do we become aqueous casting? Right here upon a successful timer. And successful timer is what? Aqueous casting gets true here if we're not already casting and we have a success timer. So this aqueous success timer is the secret. Aqueous success timer. So we go and initialize this and add it. See, look at this. We do only modify this if the element equipped is aqueous. So this is, this is where I thought, yeah, this is where we increment the success timer. Okay, let's print up the field of element equipped on our player and make sure nothing finicky is going wrong there. Because that's the only thing I could think of to do at this point. So in our debug, let's try this aqueous spellcasting, right? And it's actually is it aqueous casting? What is it? Aqueous success timer. Yeah, I guess it's just aqueous success timer. Oh, wait a second. Yeah. We should flush aqueous success timer. Let's print this up. Let's print up what the aqueous success timer is. Now, aqueous success timer is on the aqueous, or is it on the player? Okay, it is on the player. Okay, so let's do that. Okay, so see how the success timer goes up to 0.5 and then it casts, right? It builds up half a second worth. Oh, and then it freezes here. There should be a bigger cooldown. There should be a bigger cooldown. But if we swap, see, this is the issue. Our timer's still at 5. So we're still casting. Okay, I think that's it. So we just need to take this aqueous success timer upon a Flamma equip. We need to just make sure to flush this success timer when we unequip our aqueous. So aqueous success timer here. When we equip, when our element equipped gets set to Flamma, like right here, then we need to flush our aqueous success timer. So aqueous success timer gets flushed. And aqueous casting gets false, just to make sure. So let's see that. We should probably print it up still. just for us to see. Okay. Okay, aqueous success timer goes up to 5, goes up to 5. Let's make sure when we're at 5 and live there that I just quit the game. Let's try it again. We're gonna swap it out to Flamma. It got reset, so it's not spitting anymore. Great, great, great. Okay, it's still, I mean, it's still not super great when you think about adding more elements. The system's a little janky to say the least, but it's working. It's working, and the other spell is working. So we should be good to move on to the collision at this point, which is very nice. And I will probably call it here, to be honest, for the night. I mean, we could. Should we do it? Should we do it? Should we do the collision? Should we just sit down and do it? 9:40, it's a Friday. I don't have to get to bed at 10 tonight, so maybe we do it. So this is just resetting the aqueous casting upon a Flamma equip. So we can say reset aqueous success upon Flamma equip. And then you know what? Let's do the thing. Let's do the new feature. Why don't we? So right now what we're doing is we are setting a timer to turn the gecko here into splashed, which slows them down and makes them flash and changes their acceleration. So what we could do is maybe do a linear acceleration instead of tangential acceleration for the particle system. And then also have a timer to set them to become unsplashed, right? They need to reinitialize their walk speed before they were splashed, and to stop flashing blue and reset their particle system so that it can be a temporary nerf. So maybe what we can do is get the particle system where we're happy, and then go from there. Okay, so we have a thing for rain, which is another particle system we did. I'm just gonna check this out for, gosh, what line was it? We have this line where we're doing tangential gecko particle system. Okay, so we probably want to change this, right? Because we need this particle system regardless of if it's a gecko, because this is the no, this is right, because this is the purple one, but then we're saying that we've got this splash particle color, tangential acceleration. So what if we set our acceleration to linear and we just try something like, I don't know, 10? Let's just do 10s all around. I don't know. We should probably look up what the arguments are for the linear acceleration particle system adjustment, but we'll put in 10s for now and see what that looks like for the blue particle system when they come splashed here after 3 seconds, 2, 1, and not systems. System. Okay. Actually, that's look at how it's flowing down just like we want. It's actually pretty good. It looks like he's pooping it out. So we want a bit bigger of a spread. And not quite as far, right? We don't want it to go that far. what if, like, what are these first two values? It's kind of silly. You know, we could look up the documentation, but also plugging in numbers is also one way of experimenting. Okay. So 0, 0, they're still going down. I want to say it's minimum X, maximum X, minimum Y, maximum Y. Actually, that's looking, well, they're just going too far, right? And it's not, it's a lifetime acceleration, or a lifetime, what is it called? Particle lifetime issue there. So if they're going too fast, we need to just have less of a maximum Y velocity. So maximum of 4 on that Y velocity, and then we can worry about giving it a more realistic spread. Because here they go, it's like a spiral, and then now they're kind of sinking. Still looks kind of spirally though. Yeah. It's kind of looking spirally still. Oh, because we set the tangential acceleration anyway. Let's turn that off. Just particle, just linear. Let's try that. I'm still new to all the particle system stuff in Love2d, but it is fun to tweak with it. There we go. Okay, so it's only going downwards now. This is actually pretty close to what I want. It should be more, you know, like the offset, it should be kind of coming from the center of his body, not from his booty hole. You know? So it just has that effect because it's so slow that by the time he walks, it looks like it coming out of his booty hole. But we gotta spread we gotta spread the emission area. We gotta This is okay. This is okay. Yeah. So maybe we give it a bigger spread on the X, right? So like maybe it goes up to 5 on the X, and then maybe it's weird to just plop in numbers there, but give it, you know, some particle speeds will now no longer be 0 speed on the Y. So it looks more rainy like that. I do like the bigger spread. Should be a bigger spread with a minimum of around 4 or so on the X. And then the Y was looking maybe too fast on the max. Yeah, it's just a bit much. So the max should maybe be 3 or 2. X was looking okay, right? The spread on the X was looking okay. It needs to be bigger. It needs to be a bigger X spread. 20 might be way too much, but let's see. Man, you know what? I think we should go to the tangential. trying to find where we need to be. Let's see, we're back at the tangential acceleration. We're splashing blue. See, it should be more floating down. They're still floating up. It should look like floating down, I think. Let's see. Is there 4 params on set tangential? It looks cool. It looks cool. I'm not gonna lie. It's a little cluttered, right? It's, what the heck? This is X? I think this is minimum X. No, because it's 10. We'll look up after this, we'll look up the documentation, see what it says. Because yeah, that's a bit much. It's a bit much. It's kind of cool. But yeah, it does not work. It is cool. You know what? I don't think tangential acceleration can have higher gravity or anything, can it? Let's see. Okay, min and max. Literally, that's it. Okay. What about linear? Yeah. Oh, wait a second. Oh, it's minimums first. Okay, well, this will explain why we were screwing some stuff up. Let's try this again, knowing that the first 2 params are minimums. Okay, linear acceleration. What's the slowest we want our x to be? 2. Max, or slowest we want our y to be? 2. Then our maximums. Let's say, well, an x of maybe 8, 7, and then a y of, let's just say 4. Slows down. Should be a bit more spread out, but slowing down or going downwards. Let's see. So slows down. It is going downwards. It's going down and to the right. Going down and to the right. So our minimum x might be a -2 to a +2, and then, or a minimum x to a +7. So this should be a minus +7 or -7. And then our y should it be all down? It's just too spread out. It's too spread out here. So let's try maybe 3 and 3. And then minimum on the y, let's say -1 and +2. Try that. I'm kind of liking that. It should be more downwards though, right? Like it does look different. Actually, no, I kind of like it. Maybe just a faster decay rate for the lifetime. So maybe just a set particle lifetime of lesser, but I know we've had issues doing this in the past once the particle systems are knitted. Let's try to say if it's just one. Let's just see if it looks faster or if this is totally busted. Oh, it looks good. Yeah, okay, so let's give it 3 seconds. We'll have to reset the particle lifetime when we come unsplashed, right? Once we become unnerfed in the speed there. That's looking good though. Yeah, maybe a little bit more positive on the Y there. So maybe up to 4 positive on the Y max. I like that. I like that. Okay, I think that might be it. I think we like that. Now, for now we can do something like swap, just like how we're doing a timer to change him to splashed. We can maybe do a timer to become unsplashed. So I think we'll add that and then we might call it a night. So let's go check out our entity. Now we have this. If we look at our init, we've got a blue timer, we got a splash timer. So let's do this splash timer. Whenever we're doing this, we check if it's greater than 3. But what if we do... Yo, Bright, what's up, dude? What up, man? Yo, were you streaming? Were you streaming tonight? Good seeing you in here, dude. We're gonna check the splash timer here. This is just to trigger the unsplash and making sure that's working. So... if it's greater than 3, sure. If it's greater than 10, or we can do 5 seconds just to test it faster. And we can make a little variable here and call it total. What would we call it? Total splash time. Splash max. I don't know, splash max. Okay, so if we can do this. Dude, who am I gonna raid? Who am I gonna raid if you're right here? Splash timer greater than 3. Okay, so we can say that we're gonna do our splash max here at 5. And once we hit that, we're going to become no longer splashed. But then the hard part, splashed will stop us from flashing blue, but we need to re-init our walk speed to be the original walk speed we defined the entity with. And we can't just pull it from dot walk speed because we modified walk speed to be slower upon a splash. So we do need to kind of like reinitialize the original walk speed. So maybe going forward we have an agreement that the entity has a method of reinitializing its base values so that we can kind of just give us a fresh plate to start with. A clean slate to start with, I should say. Thanks, Brad. I appreciate that, dude. Oh, man. It's been good. It's been good. We only had 98 drop frames and it's been an hour 20, which it's been about 3 days of the week we can't stream at all because of internet issues, which has been really frustrating, but we're getting past it. We're getting past it. Okay, so after 5 seconds, it should become no longer splashed. And if it's no longer splashed, we shouldn't be flashing blue, but we also need to reinit our walk speed. Now I'll just leave us that note right here while we test, because we're hoping it stops flashing after 2 seconds of flashing, right? So it's going to flash 1, 2. Okay, well, he's still flashing. In the entity update splash timer, do we reset our splash timer somewhere? We just increment it. Do we do anything else to our splash timer? We don't really reset it unless it is in the init here. So that should be okay. But we're still flashing blue. We probably need to flush our values like blue flashing, because we were never resetting that. So we can say if we're past that flash max, we are for sure not blue flashing. And this is all just temporary, just to trigger it, just so we can see the behavior, right? So there's 1, 2, 3, and motherfucker still flashes. We set splash max to 5. If our timer is greater than 3 here, oh, you know what? It's always going to hit that 3. It's always going to hit that 3, so we have to pull this out. Yeah. Okay, this should do it. This should do it. Okay, so the idea here is we splash this, he becomes flashing like that, and he slows down. And then look, it turned off. It turned off. He didn't re-init. So his particle system needs to re-init to the tangential acceleration, and his walk speed needs to re-init to his original. So right here, this, let's just call this unsplash for now. Well, this will probably be a method we can just call, right? So we can say, boom, entity unsplash, re-init your original walk speed, reset your original particle acceleration, whatever it may be, because bats may have it different than geckos, which may have it different than boars, sort of deal. But where we do our tangential acceleration for the first gecko, so we have a block here called gecko particle system that has a different lifetime, right? We need a lifetime, we need a color, we need a acceleration. So we have the particle lifetime at least here. And we're going to reset the particle system to be original lifetime. We're going to set the color to be the original purple, which I think we actually have it set elsewhere, but it doesn't hurt to put it here too. We need to reset the linear acceleration, which is actually tangential acceleration for the purple. And then we need to also, well, we have that should be it, right? Walk speed is the next one, but let's just see if we get the tangential reset. upon an unsplash, let's see. So he gets splashed, blue particles go downwards. He comes unsplashed, go back to tangential. It looks right. It looks right. Yeah, it does. The tangential might be overtaking it a bit. No? It looks pretty right, actually. Oh, shit. Okay. This should be okay. Actually, hold on a sec, because if we look at that guy's purple again, so like his normal purple looks like that, kind of spreads out. Blue goes low, and then look at it's still going low. I still think this is the linear acceleration, not the tangential. Yeah, dude. Yeah, dude. There's probably better wording for that, to be honest, right? But that's what's so funny is like I work so much on the code that when it comes to writing the dialogue for the game, I literally come with the first thing that hits my mind is what I type, and then I like move on. I'm like, well, that part's easy. Let's get back to the hell. Yeah, the tangential acceleration is not quite right. But we do set it here. Yeah, let's just try to set it to something wild. Right? Like 40. And just see if it's actually reverting back. So it should go downwards. Yeah, see, it doesn't look like it's changing here. That doesn't look like 40 on the tangential. I think it's because we do a thing like with this corrupted particle. Right here. If we're splashed, well, let's see. Yeah, see, look, we're setting a linear acceleration here if we're splashed. So we could, what, do we reset the tangential here in the else? I want to clean that part up of it. Yeah, because so coding makes no logical sense, and you have to switch between real people talk and computer speak. Exactly. The switch there is a bit rough. So yeah, it makes sense. I mean, dude, I literally just danger, like literally just danger. I was like, fuck it, danger. It's been like that for 15 months. The tangential acceleration looks correct here, so I think this might have been what was screwing it, because if we do something like 40 here on the unsplash, I bet we'll get some wild shit. Yeah, okay. Yeah. That's looking right. I don't get, maybe we could print up if it's splashed or not, because, well, we have splash gets false, so it should not be splashed, but we're also setting splash to be true if we're greater than 3, which at that point of the loop, it comes back and says, well, this is greater than splash max, so let's reset it back to 3. Okay. So once we passed 5, for example, do we reset our splash timer? Probably. So, I mean, this would just make a loop of them kind of going splash to unsplash, splash to unsplash. Splash. Unsplash. Nice. Splash. Okay. Okay, this is pretty good. Wait, where's that 40? Where's that 40? Why do we have that 40? It's hard because we have some of the reset logic over there in the particle system for the gecko, which I don't quite like. I don't like that we're doing the splash logic here in the gecko particle system update in the entity class. I don't care for that all that much. But this is seemingly working. All we have left is to get the original walk speed. Okay, let's give it a bit more time on that splash max so that we can see the behavior of the particle system a bit better. Because we're hoping we get that tangential when he's corrupt, that downwards linear when he is unsplashed. Or when he is splashed. So yeah, it should go downwards. That looks pretty good. It just doesn't look... It doesn't look like it switches back to the tangential. But I guess it is, because we tested it. We tested in the particle system, in the gecko particle system. We have this, which is the default tangential. So if we put a crazy number in here, we should be able to see it doing the two different particle systems. So yeah, that's very far out. And then it slows down. So yeah, it is, as long as it goes back to wide on the purple here. Yeah. Yeah, and then it goes syncs. Actually, I kind of like when it changes like that, but it's only because if it's on a pulse like that, it looks cool. But the pulse will come from you actually shooting this guy with the water there. Okay. Yeah, you know what? Maybe we do make the blue a little wider just to make it noticeable, because if I couldn't notice it, people definitely aren't going to notice it. So let's just see. That does look different. That's for the purple. That's for the purple. Okay, I like the purple how it used to be, but I want this to have that. I think I want it to have tangential too. I don't think I'm so tied to the linear acceleration for this effect anymore, at least for the splash. Let's just see. I just want to be able to tell the difference in the particle systems. So it should go... I think we need to boost it. It should be pretty apparent of a different shift, right? See, and that's too much. It's just too distracting. But maybe we say the minimum speed is maybe 5 and the max is maybe like 14. Let's see. So he's going to become splashed here. Okay, and then when he gets cleansed, it goes back to purple. It's a little more contained. So he's kind of like leaking out, right? Let's try like a faster range. It should be pretty noticeable. it does have a bigger range now. When he goes back to corrupt, it does kind of come down. But I feel like it should be, I feel like if anything, it should probably be the other way around. Like the corruption should be significant, and then the nerf is kind of like subdued, kind of like restrained and holding him back. So for the splashed particle, maybe this is the one that's more contained, closer to 0.4. And then maybe it's just like a little bigger on the corruption. Yeah, he kind of like leaves the... Yeah. More condensed for the blue here, I think is good. Because once it hits, then it kind of dies out into more subdued, and it looks less threatening because it's a smaller surface area. When he's back to purple, it starts to grow again. I think I like that. Let's see, maybe 6 on the normal, and maybe 3, maximum of 3 for the blue. Let's see. Yeah, it should look more subdued. Yeah, look more subdued, and then grow, because you're corrupt. Grow should be bigger. Yeah, bigger surface area, and then as those die out, goes back to being small. Okay. We do set the particle lifetime of splash to be 1 in 3, and a 1 in 4 on a corrupted gecko. So maybe we say 5 seconds. And let's just say 2 seconds. Let's just mess around with these values just a bit. See if we can get a little more clear distinction. Wow. The purple just lasts too long. We can't have the purple lasting that long. 4's got to be the max. Okay. I think I like this. Then we can get the walk speed reset. Then we can worry about collision. I like it because it looks subdued. Like the instant it turns splashed, there's a big spread of them, like right there with blue, but then it kind of subdues and then follows him, and then he switches back. Okay, I think this is going to be okay. Nice. Yeah, the slow walk speed is a nice effect on there. Oh, fuck. Okay. Okay. Now we just need the original walk speed. So let's look at where we define our geckos and then kind of see if we store it as an original walk speed. Because if we just reset the walk speed, we can't reset it because we modify it to be slower. We need to pull it back and do a gecko init with the original walk speed. I know we do this in the map declarations, we call it, and we should have a gecko. Okay, well, we don't have an original walk speed. Oh. I just had a leg cramp. My bad. Oh. Okay. my gosh, that was horrible. That was horrible. Okay, this is this 5-5? This is the gecko forest by the ruins. Where's the gecko? I guess what we could do, instead of doing this for every gecko, we can just pull a copy of it into the entity class. So whenever we have this walk direction we inherit, or walk speed. Oh, original walk speed, we do have it. Original walk speed in the entity class. So when we reset it to this original walk speed, which is our defined walk speed. Our new, our walk speed will be this nerfed walk speed, but we have a copy of it here on the init, so that's good. So when we do this, this reset here, yeah, when right here, see, and I don't like, we still have this paired in the particle system. I don't like that. We have this unsplash bit, and we're gonna say that the original walk speed, or the walk speed, is gonna get reset here to the entity's original walk speed. Okay, is it camel case like that? Original walk speed should be in the entity class. Yes, okay. This should be it. Original walk speed in our, what do we call it? Unsplash, Okay. When we become unsplashed, we reset our particle system, particle lifetime, reset our flashing, reset the particle system color, reset the walk speed to be the original walk speed. So it should be nerfed. Its walk speed should be nerfed when it's blue, and then back to fast when it's purple. So he's slow when he's blue, should be fast when he's purple. Nice. And then slow again. Yes. Yes, let's go. Let's go. That's looking good. So now we need to worry about not changing it based on willy-nilly timer, but change him to be splashed here upon a collision with the actual spell, so that we can nerf this guy. Okay. I'm trying to decide if I've got enough energy for that. But we've been going on 1:40. Let me think about the collision. I'm trying to think about the collision detection for a circle on a square. And we can basically just see if in Love2d we draw the circle from the center point of the circle, and then we give it a radius. So if we're looking for a collision between the point of a circle and a square, we can see if what we can do is kind of check the center of the square and check the center of the circle, and if they are a radius or closer, then we know we're colliding. Does that make sense? Yeah, we check the difference of the center points. So we would have to, if we have the top left of entity, we would add half a tile size to the X, half a tile size to the Y, get the center point. Then we'd probably have to do the Pythagorean theorem to get the leg, right? The hypotenuse of the difference of 2 points. Because if we have 2 points to find the distance, we would just do this difference in x, difference in y. That's our a and b squared equals c squared, which is the hypotenuse leg. So once we calculate that, we compare that to the size of the radius, which is dependent on the level of spell you've got. Because what we've got here is in our aqueous projectile, we do have a spell level size. So if we were at level 2, it's a bigger spell, which would have a bigger radius, which would have, you know, higher collision, because it's a bigger spell like this. And then level 3 is even bigger. I think collision's really going to be that simple. We just check the center of the circle, compare it to the center of the square, find the difference, the distance between those 2 points, and then check if that distance is greater than the radius. Is that right? Yeah, because no, that's collision. That would be collision for if the circle takes up. Well, we're gonna have to figure it out. I'm not too worried about it. I think we can figure it out, not too hard. Yeah, part of me wants to just try to do it now, man. Let's run some tests real quick. Yeah, let's go back to our original spell level. Okay, where is our spell level in our aqueous projectile? We're going to go back to level 1. Okay. Yeah, I think we should have a mouse position, right? I think we have a mouse position. Let's check. Maybe not. The playstate has access to the mouse position. So maybe we do that. No, it doesn't. We only have it in touch detection. Okay, there's a simple it's just called get love.mouse get position. Okay. Okay. So what I want to do here is just define a square and a circle, put the circle at our mouse, and then run a couple different tests for testing collision between the circle and the square, just to see if I can come up with something myself. Like I can look it up, but I want to try to see if I can come up with some circle collision detection, and then see the real way to do it and see if it's simpler sort of deal. So we have a very simple, you pull out the X and Y from a love.mouse get position, and then you have the X and Y. So that's very, very simple. Yeah. Love.mouse get position. So right here, we're going to say love.mouse get position. Nope. Okay, and we can do local X and Y gets that position. And then we're going to print up that local X. Okay, that does look to be working. We need to get our mouse back on. We've got this like hide mouse. Set cursor. No. Thought we should have a thing maybe in main where I thought it was tab or something, tab or tilde, where we have a thing to set the visibility. Right here. Mouse state. What is this? Mouse state. Okay, we have it on touching 0. Okay, so now we got our mouse. Okay, so we have a mouse X. We want to put a circle on our X. Or actually on our X and Y. So let's go back to here. And what we want to do is render a... Hold on a sec. We want a love.graphics circle. And we want to do a fill type, and then an X and a Y and a radius. So we're just going to use the X and Y from here and a radius of, let's just say, tile size. And let's just see if we get that. Not seeing it. Love.graphics circle. That's exactly right. Love graphics circle. So maybe we just don't... Oh, we haven't. We set the color to nothing right before this. Let's do this a little lower. We'll just put it at the bottom of the play state for now. What's going on? Okay. This is just... circle collision test. Okay, we're going to pull our mouse position. We're going to try to draw a circle after we set the color to, let's just say, red. So love.graphics set color. We're going to set it to red and fully opaque, and then draw a circle at our mouse position. Okay. We've got a circle, but it is not where our mouse is. See how disconnected it is because of our virtual resolution. So we need to convert our mouse position to the virtual mouse position. I know we've done something like that before. I don't know what we do for that. I mean, it's not a huge deal. We don't need it to match perfectly, but do we do this anywhere else? Do we do this get position? We do it in the scene. Okay. Yeah, we need our mouse. I mean, I guess it doesn't really matter for this test. It really doesn't matter that it's not right at our circle, right at our mouse position. It's at the X of the mouse position, which is getting from the top left of the screen, ignoring the virtual resolution. So that's what's just throwing it off. But if we have this mouse X or get position, okay, this is okay. Now let's try to put a rectangle here. Let's just put it at one tile size to the right and one tile size down, and then a width and a height, and it's just tile size, so just tile size all around. And then we will set the color to be maybe green or blue. Okay, so I'm wanting to check collision between a circle and a square like this, because our circle is our spellcast element, and our square is our entity, or gecko, or whatever, you know, gecko or bat or whatever. So I do want to try this. We don't want a radius of tile size for our circle. We want a radius of half a tile size, so that the circle is as big as a tile, and that looks a bit more accurate, right? Okay, so now we need to see about the collision. So we could check, yeah, how would we see? So I guess, yeah, how would we do this? We have access to the center point of our circle. And which right now, if the center point of our circle is ever, because I feel like we have to compare it to the center of the square too. But I'm trying to envision it. If we draw a line from the center of the circle to the center of the circle, center of the square to the center of the circle, that is a whole tile size difference. And that is not colliding when we're perfectly side like that. But if we're down here, it's bigger. You know what? This might be okay. Okay, this might work. I'm running out of steam for the night. We made 4 commits tonight, which is very good, very good. We fixed a lot of stuff. Tomorrow I will be back and we will do the circle collision for the spellcasting, so we can trigger the splash state on entities through collision of the actual spellcast, rather than just an arbitrary time. And then we'll set like a cooldown, right? Where we become unsplashed. So we will do that tomorrow. I will work on the collision tomorrow, as well as the triggering for the splash. So that should be fun. We already made the commit for the day. Thanks for watching, everybody. I will be back tomorrow with more programming. Thanks for hanging. We'll find someone to raid, and we will call it a night. Let's see if any of the game homies are on. You know what? Oh, we got Finn. Oh, Finn is playing a game right now, it looks like, though. Let's see. Who's programming a game? Man, well, none of the homies are programming games right now. Oh, except Jitspo. Jitspo looks like he's doing it, so we will write out to Jitspo and we will call it a night. Thanks for hanging, y'all. I'll be back tomorrow. If you want to try the game, you can play online at tashio.dev. If you want to play the demo on Steam or wishlist the game, hit up steam.tashio.dev and find me on Steam. So thanks for hanging, y'all.